Hi guys, it's the educator here. Welcome back to my channel. I'm a fourth year medical student of Delta State University. It's no doubt that your examinations are very close, and so because of how this video was requested for, I decided to make this video. So in this video, I'm going to be teaching you about the nomenclature of organic compound. Okay, so it's going to be a crash course series in the sense that it is not going to be so long, but at the same time, it is going to be well detailed and explanatory. So if this is your first time in this channel, do want to hit the subscribe button to subscribe and ensure that after this video you like it, you comment on this video, and as well share to other of your friends and classmates who are going to be needing this video. So let's dive into. So all right, organic chemistry deals with carbon containing compounds. So basically, when you hear anything relating to organic chemistry, it is just telling you that the compounds involved are carbon containing compound, right? They are carbon containing compounds. And now nomenclature has to do with naming of this compound. So basically, what we are going to be doing in this series is how to name this compound. And so there is a system for naming this compound, which is the IUPAC system for naming this compound. Right? It is the standard. The standard naming. There are old methods of naming organic compounds. Right? There are old methods of naming organic compounds. Let's take, for example, let's switch to inorganic first. You hear something like tetraoxosulfate 6 acid, right? Tetraoxosulfate 6 acid can also be called sulfuric acid. But now one is the old name and one is the standard, the IUPAC, right? So the old name is the sulfuric and the IUPAC is the tetraoxosulfate 6 acid, which is being named from oxidation number, right? So just in case you don't understand what I'm talking about when I say tetraoxosulfate 6 acid being named from oxidation number, there was a previous video I dropped where I explain all of these things. So you can do well to check out that video. Alright, the title of the video is 100 JAMB real questions. Okay, 100 JAMB real questions. So just go and check it out in my channel. Alright, so organic name has three parts. So there are three parts of organic name. We have the prefix. Alright, the prefix. You should know what prefix is and you should know what suffix is. From the word pre, you should know pre is going to be in front, while suffix is going to be at the back, right? So prefix is what you add in front, suffix is the one at the back, and then the root. The root, that's the parent, is the number of carbons, all right? The parent is also known as the root. So in course of this video, you'll be hearing me say root and you'll be hearing me say parent. Once I say parent and once I say root, please just take note of it. It is the same thing I am referring to. Now, if you should take a look at this example here. Now, in your JAMB chemistry, there are two methods that you should be expecting your questions to come out in. All right, two formats basically that your questions are most likely going to be coming out in. Okay, you will see it in a condensed form like this. You see the condensed form like this one I just circled, or then you see it in a structural form more like where you have something like C, and the ones you see in your textbook and all of that, right? You can either see it like this or you see it like this. But then, whichever method you know how to name it or do the nomenclature, you can go with it. But basically, it is kind of very difficult to name organic compounds when they are condensed, except you are very good with nomenclature and you are familiar with that condensed form. So what am I trying to say? If you look at this one I just circled now, those who are familiar with it will know that it is ethanol, right? But then if you are just coming into organic chemistry and this is your first time you are learning anything about nomenclature of organic chemistry, you might not know the reason why this is organic, or sorry, you might not know the reason why this is ethanol, except you now open the structure. So it's very important for you to like open this structure. So in course of this video, I'm also going to be teaching you how to open this condensed form, because it is when you open this condensed form you can easily name organic compound. All right, and so in this video too, I am also going to teach you how to name it without opening it, all right, or how to name it faster, because it's one thing for you to know how to name it, it's another thing for you to know how to name it faster, all right, because you'll be working with time in your UTME, and it is very wise and best that you work so smart with the time. So don't go there that day and you're using 1 minute, 2 minutes to name an organic compound. It is already showing that you are missing out from that examination already. Okay, so for the roots, the parent, like I said, when I say root, when I say parents, it's the same thing. Okay, you should know when you have one carbon, the prefix is met, right? It's met. When it is two, it is et. When it is three, it is prop. When it is four, it is put. When it is five, it is pent. When it is six, it is x. When it is seven, ept, opt, non, dec. Just like that. At least the 10, you should know the first 10. All right, UTME JAMB is not going to give you anything more than 10. So it is quite necessary and important that you know at least the first 10. It's very simple. Something that you should have known all of these prefixes before now. Right? Met, et, prop, put, pent, and then you have eggs. Right? So now moving on. The suffix, right? Remember, we acknowledge that suffix is what is attached at the ending. Okay. Now, for suffix will tell you the type of bond, right? Most of the time, the suffixes that end an organic compound name tells you the kind of bond that is found, or tells you the kind of functional group that is found in that organic compound. What am I trying to say? If you see an organic compound structure, whether condensed or not condensed, so let me say you have something like CH3, CH2, and then you have CH3, for example. This tells you that all of this structure is condensed, but then it tells you that everything represented there is a single bond because there's no indication of a double bond. So what this tells us that the suffix is going to be ane, 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 right? But now, if they now tell you, or in the structure, you now see maybe there's a double bond here. You know, when there's a double bond here, these two be out of it, right? To fulfill the valency of carbon. You know, carbon has four, right? So double bond is in, ene, in, and then triple bond is yne. All right. So let's move on. So for functional group, the four basic functional groups I should be expecting for your UTME are these four functional groups. And remember, like I said, that your what you should be expecting in your UTME is what we are going to be giving you, is what I am currently giving you in this video. Organic chemistry nomenclature is broader than everything that you will see in this video. Alright, so that is why in the first slide of this video, I indicated it there that this section is a crash course. Alright, so it's a crash course in the sense that we are going to be rapidly reviewing this topic to ensure that you have a grasp of everything that you need to know. Right, you know, before the examination, when you have a long period of time, you need to know as much information as you can. But then when it is towards the exam, it is not about you knowing much information, but then it is about you knowing the things that are important. Okay, if you check your textbook, you check whatever source you want to check, you see that there are a lot of functional groups. You see about 12 functional, 20 functional groups, more than what I have given you here. But I said that this video is strictly what you'll be coming across in JAMB. All right. So all of these things is what you should expect. You have OH, you have COOH, then you have COH, and then you have CO. Right? When you see OH in any structure, what should come to your mind is that that structure is an alcohol, which means it's going to end with all: butanol, propanol, pentanol, methanol, ethanol. Right? So what this tells us is that from this OH, there's a clue. Since I know that it's going to end with all, if it is one carbon, it will be what? Methanol. Right? It's going to be methanol. If it is two carbon, it will be what? Ethanol. If it is three carbon, propanol, just like that. And it goes on like that. You can see it is very, very, very easy. So it is very important for you to know the structure of these things. All right. And for you to know the structure of these guys, it's very, very important for you to know the homologous series. Okay. So I'm going to try as much as possible not to make this video as complex as possible. That is why I am going to be breaking everything step by step. We are not going to be rushing it. Okay. So now, one thing I should take note of about in the homologous series is one of the homologous series, which is the alkane, right? Alkane. These guys are the simplest, and they are saturated, right? They have just one bond, right? When you hear saturated in organic chemistry, it means one bond. If you hear unsaturated, it means double bond or triple bond, right? So now this alkane, that is where we now have the end with ane, right? One, you have methane for one, you have methane, you have ethane for two, just like that. Then you have propane, and so it continues just like that. When you get to four, butane, pentane, hexane, heptane, and it continues like that. Now, when you come to the aspect of functional group, if one of the hydrogen is replaced with a functional group, it alters the name. So what am I trying to say? Let me clean this and show you what I am saying. So let me say you should know the structure of the simplest homologous series. So let me see methane, you have CH4, right? Methane is CH4. This is very, very common. But then if you don't know that methane is CH4, as we proceed in the video, you will know methane is CH4. But just take note that methane is CH4. And the structure of this methane, this is the structure of methane, like this. C bounded with hydrogen in four different bonds. This is it. Methane. Methane. Alright? So now, what happens if one of these hydrogen is replaced? So if I remove this hydrogen here, if I should remove it, and then let me say I replace it with OH. Let me use another color. This hydrogen that is here, I replace it with OH. So this hydrogen now becomes OH. Something happens, the name automatically changes. Alright? Remember that without the OH is what? Methane. Once I add the OH, is going to be what? Methanol. That is just what nomenclature is. So by the time you see a structure that there is OH, and then in your JAMB, you are looking at the option, and you are seeing something like one of the options is ending with A, just know that that can never be the answer. Or you are seeing something that is, once you just see OH at the end, just know that, oh, it is a functional group. All right. Even if you see it in the middle, still acknowledge that it's a functional group. But as we continue, you'll be seeing some exceptions, which I'm going to be explaining. All right. So the same thing is applicable for COOH. COOH, and just happens the same way. If we have ethane, for example, ethane is going to have this structure Ethane is going to be two bond, two carbon rather, two carbon, and then you have H all around the ethane. You have H all around the ethane, which means that it will be what? If you should count the carbon, the hydrogen around methane, it's going to be 1, 2, 3, 4, 5, and then 6, which gives us a formula of C2H6 for ethane. Now, the next functional group is COOH, which means carboxylic acid. So once you see COOH, let me now say one of these H is removed. Please take note, it is always one H that is removed to form any of these functional groups. Please take note, it is only one H, which means that if I remove one H from here, this becomes 5, right? It becomes 5. Then I add COOH. What happens? The name changes automatically. It is no longer ethane. It is now what? Ethanoic acid. So you can see the name will automatically change, and that is how nomenclature is. Ethanoic acid. If it is CHO that is added, it will be what? Aldehyde. And the name will change to what? Ethana. You can see it here. You can see the suffix. I intentionally added the suffix so that you will know what I am explaining. Alright, if it is a ketone, you see that it will change to what? Ethanol. Ethanol. Please take note, ethanol and ethanol, they are two different things. Alright, so just for the sake of knowing how these functional groups are represented structurally, I am going to be drawing the structure of this functional group. Alright, so let me quickly clean all of these. So I'm going to show you what I am trying to talk about. Okay, so let me use this. So the first one, OH, you will see it like this. It is represented like this. O and then H. O and H. This is how OH is represented. This is how OH is represented. OH. Then this place is now going to be bonded to whatever is bonded to. Maybe if it is CH3, this is how it's going to be. OH. These are the OH is expressed structurally. So you might see it in your exam. Do not just write OH. They will open the OH for you. Just know that that's how it is. Then COOH. This is how COOH is represented. Please take note. Oxygen is always double bond. Don't forget, oxygen is always double bond. This is how COOH is represented. Oxygen is always double bond. You can see the oxygen here, this oxygen here, this one I stir it. You can see this oxygen here has double bond. This one here, 1, and oxygen bond 2. Hydrogen has 1. All these bonds are based on the tetravalency, based on the valency. For carbon, it is tetravalent. So it is based on the valency. Valency of hydrogen is 1, valency of oxygen is 2. And all of these valencies have been explained in the previous video I dropped. So if you are just turning into this video randomly, and this is the first video you are watching on this channel, or maybe not the first video, but then if you are preparing for UTME and you have not watched the video I dropped recently on 100 real JAMB questions, please do well to watch that video in my channel. Just go to my channel, search for the video, and watch that video. In that video, I explained a lot of topics because it was a combination of different questions from different topics in the JAMB syllabus, and I touched almost everything. So please do well to use that video as your revision. Right? You can also use it as practice to know how many you get out of 100, but at the same time, ensure you watch that video. And what I always tell my students is don't miss anything, don't miss any update. Any update you are getting this period, ensure you hold it there to you, ensure you follow it. Look at past questions, look at anything you can look at summaries. All right, I have summaries, free summaries that I'm giving out to students. All you just need to do, indicate in the comment section. I'm going to send it directly to you. Okay, free summaries that you can access. Everything has been summarized. All the topics in physics, chemistry, biology, mathematics, English, basically for science students. All right, so whatever topic you're having issue with, I should have the summary. So what you just need to do this period, read your summaries, ensure you revise, solve a lot of past questions. Okay, so now back to what we're explaining. Now, the third one we have here is CHO. Aldehyde, CHO. This is how CHO is represented here. You have C, remember double bond, oxygen, O, and then you have H. This is how CHO is represented. Now, you might want to ask me, what is the purpose of me trying to express this thing structurally? The purpose is so that on the day of your exam, you might not see it as a condensed formula. And it is very, very important for you to know how it is opened. Okay? So that you will not just go and relate this thing as one regular compound or one regular structure. You know that, oh, this is CHO, this is a functional group. This means that the name of this compound is going to be ending with R. So it's going to be etana, metana, propana, butana, anything ending with na. That is the purpose of this. Then you have ketone. Ketone. This is how ketones are represented. They are represented like this. You have C, then you have O, and then you have. So this is how ketones are represented. So that is as for functional group. All right. So now the prefixes. I've talked about the prefixes already. I said there are before, right? So you start seeing names of structures. They'll tell you methyl pentane, methyl ethane, and stuff like that. You just see something like 3-methyl propana, 3, all those kind of things that you are seeing, they are known as your prefixes, and you should know how these prefixes are formed, right? You should know how these prefixes are formed. You should know the basic prefixes. Once you know alkane, you see this guy, alkane, this guy, once you know him, you are good to go. Once you know alkane, organic chemistry 50% has been solved already. Because now from this CH4, you have CH4. Now this CH4, remember I said it can be removed. Once one hydrogen is removed from alkane, it becomes alkyl, alkyl, right? And this tells us that if you have methane, if one hydrogen is removed, you have methyl. That is why methane is CH4. Once you remove one hydrogen, is methyl. Ethane is C2H6. Once you remove one hydrogen, it becomes ethyl. Alright, propane, you have propyl if you remove one hydrogen. And so it just continues down the group. So it's very, very important for you to know all of these structures, because you can see a compound that you just see something like this, and then you now see one side is attached, you say CH3. CH3. This CH3 is a functional group, and it is a prefix to be specific. A prefix to be specific, not really a functional group. It's a prefix to be specific, which means that it is going to have an effect in the name, and it is going to be in the front. Please take note. Prefix are always in the front. So you will not see a name like, for example, pentane methyl. There's nothing like that. You will not see a name like pentane methyl or pentane ethyl. You will either see the methyl will be in front, then you now have the parent at the back. So the prefixes are always at the front. Okay. One other common prefix that you'll be coming across on the day of your examination are the halo group. The halo group, the halogens. These guys are very, very common. Chlorine, bromine, fluorine, all of those things, they are very, very common. They bring it out, and I expect that now that you have watched this video, you should be expecting it. Chlorine, once you see Cl, you know it is chloro, it will be chloro something. If it is Br, bromo, if it is F for fluorine, you know it is fluoro, and it just continues like that. They can still bring I, which is iodine, you know that it is going to be iodo. Alright, so and that is just how it goes. Okay, so now there are rules for nomenclature, and it's very, very important that you grasp this rule, because if you don't know the rules, right, you will just end up missing out on some important details and not getting the name of that compound. Organic chemistry nomenclature can be very, very tricky, because there are sometimes that you name from the front, you have a different name, you name from the back, you have a different name. And trust me, those two names are going to be in the option. Okay, I can still remember that was one of the things that perplexed me on the day of my examination. The first question I came across in my chemistry UTME was an organic compound, naming of an organic compound. And then I named it in front. The answer I got was in the option. I named that back. The answer I got was also in the option. This was because I did not get the basic rules. I knew how to name organic chemistry compound and all of that, but then I did not get the basic rules. So it's very, very important for you to get the basic rule. And guess what? I finished that question. So then I came out of you, I realized I finished that question. So it is very important for you to know the basic rule. The first basic rule before you start to name is choose the longest carbon chain. Choose the longest carbon chain. What am I trying to say? If you have a compound that is like this, the mindset that a lot of people used to have is, let us always name it straight. The longest carbon chain must be straight. If you do it like that, you'll be wrong. You'll be wrong. Like when I say you'll be wrong, you will be wrong. So now let's take a look at this structure here. Just this is skeletal structure. Let me see their age and their other things attached to it. But the first, they said choose the longest carbon chain. What you see some people do, some people just go there and let me use another color to explain this. You just see some people go there and they will just tell you that this is the longest chain. So 1, 2, 3, 4, 5. Since it is single bond, which means that the parent name is going to be what? Pentane. But now, if you don't take note, you will fail that question. And trust me, pentane will be in the option, because JAMB knows that a lot of persons have not really gotten the basic. So your longest chain must not necessarily be straight. Your longest chain can be anything. So far, it is branched, and it is. This is what I am trying to say, right? So now, let me use another color to show you another chain that we can see here. Another chain that we can see here. This is a chain. If I say, let me start from here, take it down. This is a chain. This is a chain. And you can pick this to name. You can pick this to name it. So if you pick this, how many carbon are you going to have? You have 1, 2, 3, 4, 5, 6, and 7. 7 carbon. Which means that you will now have what? Heptane. Heptane. But you see now, because you rushed, you did not look at the longest carbon very well. What are you going to go and name? You go and name pentane as the parent. Meanwhile, it is heptane that is the longest. Another thing they can do, because JAMB can be so wicked, right? Not really wicked, but then they can be so tricky. They will not do something like this. This is just me telling you that the longest chain can be anything. You will not see something like this, for example. If you see something like this, our longest chain can change. My longest chain, I can now decide to take my longest chain like this. This will now be my longest chain. Just take a look at this. This will be my longest chain. Like this, and like this. You can see now. You can see the longest chain has changed. You can see. Let's count the number of carbon. 1, 2, 3, 4, 5, 6, 7, 8, and 9. 9. It's as simple as that. So the first and the basic rule that you must know when naming any compound is pick the longest carbon chain. Choose the longest carbon chain. Number 2 is number from the nearest functional group. That is one thing I should take note of. Number from the nearest functional group. What am I trying to say? Let me erase this so that I am going to explain it again. Okay? So now name from the nearest functional group. Let me say you have something like this on the day of your exam. You have something like this. So if you have something like this, for example, you have something like this, CH3. You have something like this, CH3. Let me say, for example, you have something like this. And then there's a functional group here, a methyl functional group, CH3. A methyl functional group. Please, this is just to explain the second rule. Please take note. This is just to explain the second rule, CH3. Now, when you want to name this kind of compound, it is very, very important for you to pick your functional group from the nearest. Start counting from the nearest. Your counting should not, let me say this is your left and this is your right. Your counting should not always be left to right. Your counting can be from right to left. So what am I trying to say in essence? What I'm trying to say in essence is this. If I decide to name this compound from left to right, I'll have this is going to be 1, this is going to be 2, this is going to be 3, this is going to be 4, this is going to be 5, and this is going to be 6. Right? Now, what this means is that the functional group, the first functional group is in which carbon? The first functional group is in carbon 2, and the second functional group is in carbon 4. So if you want to name this structure, we'll now be having 2, 4, something. This is how the numbers are got, 2, 4. Don't worry, we'll get to that properly. I'm just trying to explain what all these rules mean. Right? 2, 4, then the name. Now, I can decide to name this compound from the back to the front. If I name it from the back to the front, this is going to be carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and then carbon 6. So which means that the first carbon, the first functional group is going to be in carbon 3. So I have 3, 4, 5. 3, 5, then the name. Now let me teach you a trick for naming organic compound. If you get to the examination, or this is not me encouraging that you should not understand organic chemistry nomenclature very, very well. But then some questions can be they can just be tricky normally, like tricky naturally, and then you just get confused and you don't know how you go about it. If you see a particular organic compound, right, and they give you the structure, and for example, what the first option is maybe 2,4-dimethyl-pentane. The second one is 3,5-dimethyl-pentane. The fourth one is 4,6, just like, for example, just like this, 4,6-dimethyl-pentane, right? For example, then the last one, any option. Once you see this kind of question, your answer is most likely going to be 2,4-dimethylpentane. 2,4. Tell me why I'm telling you it is 2,4-dimethylpentane. It is 2,4-dimethylpentane because you name from the nearest functional group, which means that if it is possible that this compound can be 2,4, then why are we picking 35 as the name? Do you understand what I'm trying to say? Now, this trick I just gave you is if you don't know what to do on the day of the examination, or there's every tendency that the probability that the lowest number there is going to be the answer is very, very high. But please take note, this does not replace you actually solving or actually decoding the name. So don't go to the exam hall on that day and just assume that anytime anywhere I see small number, that's the answer. Please take note. It is very, very risky. If you don't know the name, if you try to know the name, you try to decode the name, the structure is a bit perplexing, or you are seeing some new terminology or some new functional group that you don't understand, it is best that you pick the lowest number there. Right? You should know how to get your parent carbon, the root. This is the first rule. Choose the longest carbon chain. So longest carbon chain should not be a big deal. Once you are getting your longest carbon chain, you should know that some answers should be eliminated, because that's what JAMB does. They'll pick the one that many people will go for, and then they'll pick the right one. So you see some options, 2 will be pentane, 2 will be octane, or 2 will be another thing. So by the time you know the parent carbon, you have streamlined your answer to just one. You can see, you have streamlined your answer to just 2 options rather. So you should have streamlined your options to just 2. So it will be very, very easy for you to just pick the answer, and then you are good to go. Then the next thing is to identify the substitutes, the substituents, right? You should identify the substituents. That means those things that were added, right? Those things that were added, maybe CH3, methyl group, identify them. Identify them. Rule 4, use lowest possible number. You can see the rule is coming again. Use lowest possible number, which means that if you name from the front, you are getting 2, 4. You name from the back, you're getting 3, 5. Don't even think twice. Don't think twice. The answer is 2, 4. The lowest possible number. Please take note. And another rule that people fail to understand is write name in correct order. Write name in correct order. Though JAMB is not really going to test you for this, right? They will not test you for this. But then there are some international exams that they do test. Okay, they will just mix it. They will put pentane in front, put methyl at the back. So you should know methyl is supposed to be in front. Methyl pentane or methyl propane or whatsoever is meant to be at the front. You get what I'm trying to say? Now, another rule that I should take note of, though it's not here, is you should name alphabetically. Once you see that there are a lot of functional groups in the structure, always name alphabetically. And there is one question that JAMB normally repeats, where they are just going to put a lot of halo group. They'll put fluorine, put chlorine, put bromine and stuff like that. You should start numbering from the one that is the first in the alphabet, which is bromine. So wherever bromine is, that is where you are going to start counting from, where the closest to bromine. And that is how you will now be able to name the structure. So the examples we have here, these are the condensed form. Like I told you, these are the condensed form. And then let me just use this condensed form to explain how you can open it, the short method and then the long method. But most especially the short method, because that is the one that is going to be helpful for the nature of examination that you are preparing for. So once you see this kind of structure, because this is what is going to be given to you on the day of your exam, most likely they will put this dash. But then if they don't put this dash, this stuff I just circled here, it's the same thing as just writing CH3, then CH2, CH2, and then CH3. It's the same thing. Just take note, please. It is the same thing. Whether they put the dash, that's the bond, or they don't put the bond, just know that it is the same thing. So you can decide to put the bond. The first thing that you do is when they give you a condensed form, like this one here, I just wrote here, the one here. The next thing that you should do is to express it in condensed form. You express it in the next condensed form, which is now putting a bond, which is this one that is given in this example. So you now put the bond. Once you put the bond, case closed, you're already good to go. Right? You're already good to go. From here like this, you already know that this is already propane. How many? 1, 2, 3, and it's a single bond. You already know it is propane. Right? You should always know that the ending and the middle, the ending is always CH3. Please take note. The ending is always CH3. So if you see, what does this mean? If you have a carbon compound that is long like this, for example, you have a carbon compound that is long like this. Let me see pentane. Pentane. You know this is how it's going to be. Like this, like this. Then you have H here. Then you have H here. Then you have H here. If you should condense this guy, this last one, what are you going to have? CH3. This is what I mean by the last is CH3. So this is what this structure here means. CH3, the last from one end. CH3, the last from another end. Then the middle is always CH2. The middle is always CH2. If it is double bond, the middle is going to be CH. If it is triple bond, the middle is just going to be C. Please take note of it. So what am I trying to say? If you have double bond, if I decide to put double bond here, automatically it means I'm removing one of the H here. So the middle now becomes CH. It's as simple as that. It is very, very simple and straightforward. Right? So it now be CH2. This one is going to be CH2. The end here is going to be CH2. And then you have double bond. This is still going to be H. Remember the tetravalency rule. Carbon is now going to be bonded to 4. So this is going to be CH. So if it is double bond, you have CH in the middle. But if it is single bond, the middle is always CH2. The middle is always CH2. Right? So what this means now is, if I'm giving a structure just like this, if I'm giving the structure like this, and then I am told to name this guy, this is how you are going to go about the naming. The first thing is to open all of these structures. Now, this is the short method. The short method is this guy. What you just need to do is to put a bond in between them. Once you put a bond in between them, you already know that one end is going to be CH3, the other end is going to be CH3, the middle is going to be CH2 if it is single bond. So you just count 1, 2, 3, and you name propane. It's as simple as that. Now, let us use this structure here to explain the short method. You can see one of the end is CH3, the other end is also CH3, right? So what does this tell? This tells you that the parent carbon is going to be alkane series, right? Alkane series, because you can see that it is single bond. But now there is something I take note of, that there is OH. If you see anything in brackets, any condensed form, if they put OH in brackets, condensed form, OH in brackets, just know that that OH is a functional group. If they put CH3 in brackets, you should know that the CH3 is a substitute, right? The substituent. Just take note of that. Take note of that. So what does this mean? This means that if I should expose or open this guy. This is how it's going to look like. C, C, and C. See why I'm doing it. C, C, and C. We don't need to open the ending. This ending we don't need to open because we already know that the ending is going to be CH3, CH3. So let's just leave it like this, CH3, and then we have CH3. So our concern is the middle, right? The middle. The middle is meant to be CH2, right? So the middle is meant to be CH2. So one H should be here, and then another H should be here. But now this question says that one of the H was removed and replaced with something. What was it replaced? It was replaced with OH. OH. So it means that one of the H you have OH. So this gives us proper no. Remember I said it when I was explaining functional group. I said immediately one H is removed and then another one is added. The functional group is added. It automatically changes the name, but it will not change the parents. Please take note. So you will not have maybe propane. One H is removed. It will now become butanol. No. Once one H is removed from propane and OH is added, you will have propane. It's as simple as that. Okay. So now let's go into normal exam question and how you are going to come across them. What is the IUPAC name of CH4? Remember the way we do it. We start from the simplest to complex one. CH4, we already know CH4 is methane. By now, you should know CH4 is methane. Right? CH4, this is CH4 here. Methane is the simplest in the homologous series of cane. Alright? Question 2, what is the IUPAC name of C2H6? C2H6 is going to be ethane. Alright, just in case you want to know the formula for all these homologous series, the alkane, alkyne, alkene, all of them, there's a crash course. There's a crash course document I have. It is a summary of organic chemistry. Okay, so if you are interested in it, you can do well to indicate in the comment section. I'm going to drop a link that you're going to use to reach out to me on WhatsApp and then request for it properly, and then I just need to send you the link to access all of these materials. They are totally free. So just in case you are seeing all these numbers and why is C2H6 18 and stuff like that, these ones are already fixed. Okay, if you come across this kind of naming of organic chemistry and they are giving you a compound that is already fixed, it is a bonus question, right? If you see CH4 and they're asking what is the name of CH4, it is a bonus question, right? So this is not where we are going to be putting our focus because all these ones are fixed. So it is left for you to now know the homologous series. You should know the trend in the homologous series. You should know their formula. Then you can now get all these ones and you know it is straightforward. Okay. Then C3H8, you have propane. Right. So moving on, what is the IUPAC name? This is where we now want to go into properly. Remember, when you see this kind of question, the first thing that you should take note of is to open it, right? I said you should open it. So by opening it, so that you not confuse yourself, because if you combine it like this, only pros, people that are already so good with organic chemistry, you don't need to open it. But now, if you are still learning, please ensure you open it. So if I open it, I'll open it like this. I'll open it like this, and then I have OH. So what does this tell me? What does this tell me? This tells me that how many carbon are here, first of all. The first thing, remember, the first rule is to know the parent carbon, right? So the first thing is how many carbon are in this particular question. How many carbon are in this question? You have 2 carbons in this question, which means that most likely the formula is going to be something X, something maybe ethanol or whatever. But then you already know that it's going to be ethanol because you have OH here, right? You have OH here. And when you see CH3, CH2, you see 2 carbon, carbon 1, carbon 2, it is what X. So you have ethanol. You can see how opening it just makes it easy and straightforward, right? Then what is the IUPAC name of this guy? CH3. Remember, the first thing is to do what? Is to open CH3 and then you have OH. The ones that you are used to, you don't necessarily need to open it, okay? And I'm just opening it for the sake of clarity and proper understanding. All right, so you have how many carbon here? You have 1 carbon, which means that it is met. It's going to be met. And OH, so it's going to be what? Methanol. All right, it's as simple as that. The next one, you have CH3COOH. You know what COOH means? COOH means it's going to be nucleic acid, right? It is going to be nucleic acid. It's going to be nucleic acid. So you have CH3, then you have COOH. COOH. How many carbons are in this structure? How many carbons are in this structure? You have carbon 1 and then you have carbon 2. Don't mind me, I did not put bond though, but then let me just put the bond for the sake of opening it. So if I put my bond here, how many carbon? You have carbon 1 here and you have carbon 2, which means that it is going to be X. COOH is what? Nucleic, which tells us that it's going to be what? Earth and nucleic acid. Please be very, very careful when you come to carboxylic acid and esters. Don't worry, I think there's a question for esters. I added a question for esters. Please take note of those two because those two can be so confusing. All right. So now, if you open it like this, let me say, for example, you open it CH3, and then this is the bond. Let me open it very well so that you will understand what I'm trying to say. Don't say that this is CH3, so this is how many carbon 1. Then you neglect the carbon that is in the functional group. Then you now say this is methanoic acid. Please, it's not methanoic acid. Count the number of carbons present, whether the carbon is in the functional group or it is not in the functional group. So far, it is present in that compound. That is what you are going to count to get the parent. I don't know if you understand what I'm saying. So you have carbon 1 and you have carbon 2. That is why it is ethanoic. Methanoic is going to have 1 carbon, and methanoic has this structure. Just H, then COOH. That is methanoic. It's as simple as that. Okay. So what's the IUPAC name of CH3COO When you see CHO, you already know that it's a functional group, Abi. Alkanas, CHO. Then the first thing that you should take note of is what? How many carbons are here? So you have CH3, right? CH3. Then you have CHO, right? Then you have CHO. How many carbon? 1 carbon, and then you have 2 carbon, which means that it's most correct answer, ethanol. Please, like I said, when you open it, don't just say CH3, CH3 is metal, and you just want to pick methanol. Please, it is ethanol, right? So the next question, what is the IUPAC name of this structure? What's the IUPAC name of this structure? So you have CH3, we are going to open it, CH3, COCHH. So CH3, then we have C, then we have O. This is how you open this kind of structure because they are one. Don't go and join CHO, CO together. It is separate. You open, this is how you open it, right? Now remember that when we were doing the functional group, we said something about CO. Now whenever we see CO, there's something that comes to the mind. CO is a functional group for which carbon? The ketone, right? Ketone. And what is the name that is given to them? It means that to end with what? Non. So maybe propanol, ethanol, butanol, non. So if you look at this, how many carbons are present? Let's get the carbons. 1, 2, 3. So what's the parent? 3, which means it's what? Propanol. So we have propanol because of the functional group. Why is it not propanol? Because there's no OH. Why is it not propanol? Because there's no CH. You can see it is very, very simple. Once you know the basics, you are good to go. Question 9. What's the IUPAC name for C2H4? This is also these ones are fixed. So please, you should know them. 18. All these ones are fixed already. So no stress about it. What's the IUPAC name of C2H2? You have ethine. You should know their structure. This is the structure here. That's why it is C2H2. This is the structure here. H, and then you have H. You can see this carbon here has 4 bonds. This carbon here has 4 bonds. You can see, right? So ethine. Next question. What's the IUPAC name of? Good. We are now proceeding. When you see stuff like this on the day of your exam, don't be scared. All right, don't be scared. Don't worry about it. Don't be scared. Once you see this kind of thing in your exam, there's no need of you opening. Once you don't see that there is no bracket. If you see that there is no bracket, it means that there's no functional group. So there's no need of you opening. What you just need to do is to count the number of carbon and pick your answer and go. What do I mean? So carbon 1, carbon 2, carbon 3, carbon 4. Which means that our answer is going to be what? Butanol. It's as simple as that. Sorry, it's going to be butane. Alcohol don't master me. It's going to be butane. Please take note. It's going to be butane. But then for the purpose of clarity, let me still open it. So we have CH3, then we have CH2, right? Then we have CH2 again. Then we have CH3. Remember I said the middle is always going to be CH2 if it is single bond. Then the two ends is going to be CH3, right? So if you count it, you get it, butane. What is the IUPAC name? Good. We're already getting into some interesting questions that you'll be seeing. Please don't mind the options. The options might not be as simple as this. So, the options if you look at these options that are in this question, you see that the options are something that you can just easily know that is the answer. At the end of your exam, you will see that the options are going to be very, very similar, and it is not going to be so simple the way I am making it this simple. But then if you understand the basics, you are good to go. Right? So if you look at this, the first thing you should know is to what? Is to open, right? Is to open. That means put your bond. CH. This CH, what does this mean? It's supposed to be CH2, Abi. Middle is supposed to be CH2, but when you see CH, it means that the other H has been replaced with something. So you have something like this H here, then the other H has been replaced with something. What is it replaced with? That's what you put in this bracket. So you have the other one is replaced with what? CH3, right? Then you have the ending to be CH3. It's as simple as that. CH3. So the first thing is the longest chain. What is the longest chain here? Now that you have opened it, you know the longest chain. It's questions like this. When you are seeing carbon everywhere, you should pick your longest chain. Please don't go and do, because some students can be very funny. Don't go and do longest chain like this. It is very dangerous. Please don't do longest chain like this. You say carbon 1, carbon 2, carbon 3, and carbon 4. Please, it is an error to do longest chain like that. how you get the longest chain is by following the bonds, right? By following the bonds. So I've removed my structure. By following the bonds, you will get the longest chain. Okay. So now let me just use this. You have CH3 here, and then you have H here. Then one end you have CH3, you have CH3. The longest chain there is going to be 3 carbons. So 3 carbons already tells us that it's going to be what? Pro something, prop something. So which means that this butane that is here is wrong. This pentane that is here is also wrong. So it's either propane or 2-methyl propane. But then there's a functional, not really a functional group, but a substituent. The substituent has been added. So this substituent already changes. Remember, substituent, the prefix. A prefix has been added. What is this? This is methyl. And which carbon was methyl added to? If you name from the front, you have 1, 2, 3. That's from back to front. If you name to the back, you have 1, 2, 3. So whichever way you want to name it, this methyl still forms in the second carbon, which makes your answer to be option B, methyl, 2-methyl propane. All right, so let's move on. And now it is getting more interesting. Okay, so what you need to do here is to open. Right, we already seen OH here. We already seen OH, which tells us that it's going to be what? It's going to be an alcohol. So it's going to be ending with no, right? It's going to be ending with no. It's going to be ending with no. So you have something like this, and then you have OH, and then they ask you what's the name of this compound. That's what this thing just means. So this structure that I'll give it to you, this is what it means, right? The first thing, count the number of carbon. Remember, always remember the number of carbon. How many carbon? 1, 2, 3. Functional group OH, which gives us propanol. It's as simple as ABC. And the next, what is the IUPAC name of this guy? You can see we're already getting to some interesting nomenclatures. We are getting to some interesting nomenclatures already. So now, how do we name this? The first thing you need to do is to what? Is to open CH3, CH3, CH. Whenever you see CH, it tells you, remember I said the middle normally is meant to be CH2. But whenever you see CH, it should give you a signal that wait, something has been removed and something has been added, right? And what has been added is always in the next. What has been added? They added what? Chlorine. Chloro. They added chloro group. So Cl. You can see now chloro is already coming in. And you have your CH3. The first thing to do is to what? Pick your carbon. Longest carbon chain. Longest carbon chain. This makes this what? Propane. Prop. Not propane now. Prop. Which means that our parent is what? Propane. But that's not the name of propane. But now the one of the rules now tells us that the substituent that is added will be at the front as a prefix. You remember that rule, right? So which means that what is the substituent that has been added? Chlorine. But if you look at this option, you see one of the options is 2-chloropropane, one of the options is 1-chloropropane. So what exactly is the correct answer? All you need to do is to count. So you have 1, 2, and then you have 3. Where does chlorine fall in? 2. If you decide to count from here, 1, 2, 3. Where does it fall? It is still 2. So the correct answer is 2-chloropropane. Alright, what's the IUPAC name of this? So when you see something like this, it also gives you a clue that what your name is going to be is New York. Alright, your name is going to be New York. The name of the organic compound is going to be New York. So the first thing to do is to count the number of carbons. Remember the rules. Even the functional group has carbon, count it along. You should count it along. So you have 1, you have 2, and then you have 3. So what this gives us? Propanoic acid. What is the IUPAC name of this guy? It tells us that this guy has a functional group CHO, which is going to be what? Alkana, right? How many carbons? 1, 2, and then we have 3, right? So this tells us that it is what? Propana. Tells us that it's propana. Alright. So now, moving on, we have what is the IUPAC name of this structure? Alright, so I already seen something tricky here. The first thing you should know is to know the mother, the parent carbon. How many carbons are here? First, let's divide it so that we know the number of carbons that are here. So this division is the bond. That's if we open it, if we decide to open it. So in subsequent explanation, I'll just be putting the division for all these simple ones. But the complex one, I will intentionally open it so that you understand what I am talking about. But for these simple ones, once I put the division, you should know that this is what I'm trying to talk about. Okay. So the number of carbon, how many carbons are here? That's the first thing I should know. 1, 2, 3, 4. 4 carbons are here. What's the functional group? When you see CO, this functional group is always in the middle. It's always in the middle. You always put it in the middle. Right? If you see this functional group, it is always in the middle. and it is not with any H, or it is CO. You see it as CO. You not see it as maybe H, or they'll put H somewhere. You see it as CO. Please take note of that. This O can, remember that the O is double bond. Please take note, so it's not just O like that. The O is a double bond, right? So now, what this tells us is that this is a ketone group. It's a ketone group, which means that the name is going to be non. Non. What is the number of carbon? 4, which means that the name of this compound is butanon. Alright, so let's move on. Okay, so we're getting closer to some interesting nomenclature. So you divide. By the time you divide, you have, what's this guy? Bromo, right? Bromo. How many carbon? 1, 2, which means this is what? 18. So the name of this compound is going to be what? Bromoethane. Bromoethane. It's as simple as that. So moving on, what is the IUPAC name of this? Good. We have seen something long now. Some people will fear that, hey, remember the rule I told you that when you see something long like this and there is no comma, so if you look at it, CH3 correct, CH2 correct, CH2, that means the middle, all of them are CH2. Don't stress yourself, just count the number of carbon and then pick your answer. The number of carbon, you have 1, you have 2, then you have 3, then you have 4, then you have 5. What does it tell us? It tells us that the answer to this question is pentane. Pentane. Alright? So now, moving on. So you come across questions like this too. You see CH. This one, they're now putting double bond. They're informing you that, wait, so this is not your regular alkane. Once you see double bond, you should know that the series has changed. The word alkane. That is what the series has changed to. Alkane. Right? So when the series has changed like this, it is still the same rule that is applied. Remember I said when it is alkane, the normal one, the middle is now going to be what? CH. So you can see it is still normal. There's no abnormality there. It's still normal. So what you need to do is to count the number of carbon. 1, 2, and then 3. So this is going to be what? Propene. Please take note. Remember we said it is now alkene group. It is now alkene group. Alright. So it's going to be propene. Please take note. Next. Okay, we have done something like this before. We have done something like this. I drew it for you guys. So you have ethane. Ethane. Okay. So moving on, what's the IUPAC name of this guy here? The IUPAC name of this guy. You can see everything is normal. You have CH3, yes. CH2, yes. CH2 in the middle, yes. CH2 again in the middle, yes. Then you have OH. This means that it's going to be what? No. Right? It's an alcohol. So 1, 2, 3, 4. 4. So the answer to this question is butanol. Compound is butanol. Alright? Number 23. What is the IUPAC name of this guy? You can see there is a functional group, or rather, there's a prefix, there's a substituent that has been added to this guy. So what you need to do is, the first thing you need to know is to divide. Divide here, you divide here, right? And then you divide here. This is just how it looks like. Then the next thing to do is to count the number of carbon. Please take notes. Don't just rush and go and count 1, 2, 3, 4, 5. You go and pick pentane. You just end up feeling it. This is no longer pentane, but rather an isomer of pentane. If you look at it, if you have read the organic chemistry, this video is not to explain in details some organic chemistry concept. It is strictly for nomenclature, and that is why I've not stressed myself past nomenclature. Okay, by the time you go through your textbook, the summaries I did, and some other material, you see that all of these things have been highlighted here. All right, there's something known as isomerism. Okay, so now let's open this for the sake of clarity, so that you will not confuse yourself. Let's open this. You have CH3, right? Then you have CH2, right? Then you have CH. You can see normally it's meant to be CH2, right? Because it's single bond, meant to be CH2, but now it's not CH, which means that something has removed H. What removed H? CH3. That is what removed H. CH3. That's what removed H, right? CH3. Then the last one you have CH3. Pick your longest chain. That's the first rule. Don't pick your longest chain. If this is the longest chain, you pick it. How many? You have 4. What is it? Butane, right? But now you also have a substituent, which is what? Methyl. So if you count, now take notes. In JAMB options, you can see these options I'm giving you is simple. There's no confusion there. In JAMB options, you see 1 methylbutene, 3 methylbutene, 4 methylbutene. How you know the answer is? If you count from left to right, you have 1, 2, 3, and 4, right? So this name is going to give us 3 methylbutane, right? But now let's name from the back. We have 1, 2, 3, and then 4. What does it tell you? If you name it from the back, you now have 2 methylbutane. And one of the rules says that pick the smallest. Pick the smallest. So our answer is going to be what? 2 methylbutane. It's as simple as that. 24. What's the IUPAC name of this guy? I'm already seeing CO. Once I see CO, what comes to my mind is a ketone, right? The next thing is to count the number of carbon. 1, 2, 3, 4. What's the number of carbon? So the answer is going to be butanol. You take note, butanol. Then what's the functional group of this guy? This is the esters I was telling you about. The ester I was telling you about. Okay, so I'll use this particular because I think this is the only ester question I added to this nomenclature. Once you see something like this, that is no longer CO that is in the middle, but what is in the middle is COO. Just know that you are dealing with esters, right? All right, so dividing it, use the COO to divide it into 2 because that's the way the name used to be. That's the way the name used to be. Once you divide it into 2, you have gotten the name. How? This is how you divide it. Once you see anything like this, you just know it's esters, and this is how you divide it. So you have, this is the first part, and this is the second part. But the naming is from back to front. The naming is from back to front. Please take note. The naming is from back to front. When you see OOO, OOO is gotten from OCOOH. Sorry, COO is gotten from COOH. That means if you remove one H, this carboxylic group will now become ethanoate. Oh, sorry, alkanoate group. So alkanoate group is just COOH converted to COO. Take note of that. Now let us name this, which means that how many carbons are here? 1, 2, 3. 1, 2, 3. Prop, right? Prop. Please take note. Prop. But COOH, I've given you another functional group or another name that you can use. So since it is prop, and I told you that when it is COOH, there's a name that is not added. It's going to be what? Propanoate. Sorry, not COOH, but COO is going to be propanoate. Propanoate. What's the second part? The second part is CH3. You know what CH3 is already now. Nobody should by now not know what CH3 is. Methyl. Now the naming is from back to front. So which means that remember that methyl is a prefix. So prefix must be in front. You cannot say propanoate methyl. It will be methyl propanoate. And that is how you name this esters, right? So you can go back to your past question, review more naming on esters, because I know for some persons it might be very, very, very complex when they are seeing esters, because I know it was something I experienced. Naming of esters can be so complex. But I believe after this video, you should know how to name esters by now. So what you do for me now is to go back to your textbook, go back to your past questions, or you can go back to whatever source you want to go back to. You can ask from AI sources or just check Google naming of ester. This ester in particular is something that you should expect. It's something that you should expect, but then the exact ester that is going to come out, you can't tell, but just know how to name it. Okay. So if you don't know how to name esters before, but after this video, what you have learned now, please go back. You can ask Google for, please give me 5 esters, or maybe AI, give me 5 esters. I want to name them. If you are able to name them, please come back to the comment section and indicate that you now know how to name esters, because I will be so proud of you, because you are already ready to dismantle this exam. So let's move on. What is the IUPAC name of? So we are already entering some kind of funny. I intentionally added this, though I did not highlight it as a functional group. So I just added it though. It does not still change. It does not still change. This is a new functional group, NH2, which is amine. Amine. That's the functional group, amine. These are advanced organic chemistry. Advanced organic chemistry. Organic chemistry in form of biomolecules. That's protein, carbohydrate, lipid, and stuff like that. So amine. So 2 carbon, 1, 2. 2 carbon, you already know is going to be et. So you have ethylamine. It's as simple as that. 27. What's the IUPAC name? So you have something like this. This is the IUPAC name. This is structure given to you, and they say what's the IUPAC name. Remember, this is still the same functional group, right? It's just a different question. You have amine. Amine. So what you need to do is count number of carbon 1, 2, 3. So this is going to be propylamine. Propylamine. It's as simple as that, right? So yes, moving on. What is the IUPAC name of this? IUPAC name of this. When you see something like this, you should just know that it is an ether. Ether. There's another functional group, ether. Or there's another. Are we going to say homologous series now functional group? Ether. Right. Once you see O in the middle, once you see O like this in the middle, O, oxygen in the middle, just know it is ether. Right? Ether. So if you separate it, you have CH3 here, CH3 here. That gives us 2 ethers, 2 methyl, which makes it dimethyl ether. Dimethyl ether. You already know it's not even going to be methanol. There's no OH. It cannot be ethanol. There's no OH. It cannot be propanol. There's no OH. Right? So moving on, what's the IUPAC name of this guy? So the ether has a way of naming it. The ether has a way of naming it. And now, how do you name ether? Ether is the same thing with ether. Please take note. Ether is the same thing with esters. The same way you will name ether is the same way you will name esters. What am I trying to say? This is what I am trying to say here. So you are dividing it into 2 like this. I divide it into 2 like this. So once you divide it into 2 like this, then you name, right? You name. Remember, this oxygen is sharing a bond here, is sharing a bond here. So you know, normally, what is this supposed to be? Normally, CH3, you know that this is meant to be met, right? Met. Then this one is going to be earth something, right? Earth something. So this is how you name ethers. Remember, it is from back to front. The same way we name esters back to front. Now, this guy here is known as methoxyl. Methoxyl. How many carbon? 1. And because of this oxygen, you call it methoxyl. Methoxyl. Right? Then the one in front here, this is what? Ethane. This is from ethane, right? The one in front is from what? It's from ethane. So you end up having methoxyl ethane. It's as simple as that. Methoxyl ethane. Alright? Question 30. What's the IUPAC name of this guy? Okay. I've seen something like this before. Chlorine is added. You have CH2 normal, CH2 normal. You just count number of carbon. 1, 2, 3. So propane. That's going to be chloropropane. But next thing is, what is the chloro exactly? Alright. What's the chloro exactly? Which chloro? So let's just open it so that we know the number of the chloro. So we don't just end up guessing. Alright. So we have CH2. Then we have CH2 again. And then we have Cl. Cl. What does this mean? This tells us that Cl is attached to what? The last. Remember, the last is always CH3. Remember the two ends. Please don't forget this rule I'm giving you. The two ends, CH3, CH3. The right in the middle will be CH2. But now there's combined the last end is now CH2 because one of them has been replaced. One of them has been replaced. So you will now have something like this. This is how the structure is now going to be like. So let me clean this. So the structure is going to be like this. So you have H here. And then you have H here. Right? So which carbon is this associated with? If you start from here, you have 1, 2, and 3. So we can have 3 chloro, right? 3 chloropropane. If you start from here, you have 1, 2, and then 3. You have 1 chloropropane. What does this tell you? Pick the what? The lowest. You have 1. Alright, so now let's move on. Now, most likely you are going to be seeing some questions like this. Remember what we just treated now are the condensed form. Why some they are going to open it for you? You see, like it will be opened. They will open it for you and they'll tell you to name it. Okay. So now this question just tries to tell you this is not really nomenclature per se, but then we can still name it. Alright. So but we are just going to strictly answer the question. It's not nomenclature per se. This question just trying to tell you to identify the type of compound that this structure is. Okay, in alcohol, there's what we call primary alcohol, secondary alcohol, and tertiary alcohol. This is the only explanation that I'm going to deviate from nomenclature for the sake of this question. All right, this is a structure. For example, 1 carbon. If you have 1 OH attached to 1 carbon, it is primary. If you have 2H attached to that same carbon, it is secondary. If you have OH attached to 3OH attached to the same carbon, it is tertiary. All right. So now let's pick one of the carbons, any of the carbons. We already know that this is having 2OH. So automatically it is dihydric. It is not monohydric. So option B is wrong. Option D is wrong. So we know it is either tertiary dihydric or primary dihydric. So now let's solve. Let's pick one of the carbon. Let's pick this carbon. Let's pick this carbon. This carbon has 1 OH. Then no other OH again. Let's pick this carbon. This carbon does not have any OH. Let's pick this carbon. This carbon has 1 OH here. Does not have any OH. So all the carbons they just have 1 OH, which tells us that it's primary and dihydric. Don't go and say 2 OH means secondary. Please take note. It is for the same carbon. So look at it. The OH, is it for the same carbon? That is how you get it. Alright? That is how you get it. So now, yes, let's solve this. What the IUPAC nomenclature for this compound? This one is already opened already, so they just want us to solve it, right? It's a very, very sweet question. So let's attempt this. Now, if we want to name, we can decide to start counting from here. 1, 2, 3, 4, and what? 5. So what's the parent? You already know the parent is pent, right? Pent, pent, pent. Now you can see that we already know it is pentene. Abi, we know it is pentene. But you can see that there is a new style. They are now putting number in the middle. So it's now pent something in. Pent 1 in, pent 2 in. What that thing just tells you is where the carbon or which carbon is carrying the double bond. That's just what it means. So is it carbon 1 that's carrying double bond, carbon 2, carbon 3. So the way we named it like this, which carbon is carrying the double bond? 5. Is there anything like pent 5 in this place? There's nothing like pent 5 in. It's as simple as that. There's nothing like pent 5 in. The highest number you can have is that number divided by 2. Approximate it. What am I trying to say? If you have pent 5, pent is 5. If you divide pent by 2, you have what? 2.5. If you approximate 2.5, you have what? 3. So the highest number that you can get for pentane is, pentene is 3. So you can have pent 1 in, pent 2 in, pent 3 in. There's nothing like pent 4 in. There's nothing like pent 5 in. What am I trying to say? Now, this double bond is here, which means that the correct numbering is meant to be 1, 2, 3, 4, and 5. Whenever you see a double bond, respect it. Whenever you see a double bond or a triple bond, respect it. That is where you are supposed to start counting from. Don't want to start counting from the opposite side. It is whenever you see double bond, you say, Tuali, I respect you, sir. And you start from there. Right? So now, which carbon has this double bond? It is the carbon 1. If they move this double bond to this place, it will be what? Carbon 2. If they move this double bond to this place, it will be what? Carbon 3. And it just continues like that. So you have carbon 1, carbon 2, carbon 3. It's meant to be carbon 3, right? It's meant to be carbon 3. But now, if you look at this, if we start naming from here to be 1, 2, 3. So the double bond is the third carbon. If we start naming from here to be 1, 2, 3. So that is why you have that your highest is going to be what? Your highest is that the highest you can have. If the double bond is here, for example, you will not go and say 1, 2, 3, 4. That means it is pent 4 in. You are wrong. You will start from where? You now start counting from where? This place, because this is the closest. You start counting from here. You start counting from here because this is the closest. So it will now be 1, 2. So you can have pent 1 in, pent 2 in, pent 3 in, but you can never have pent 4 in. What formula did I use? All these things are tricks. That once you see an option that is pent 4 in, you just smile and say, JAMB think I'm foolish. The same thing is applicable. If you see something like boot, let's take boot. Let's take butane, for example. Butane. The highest you can have for butane is 2. Why? Butane is 4. 4 divided by 2 is what? 2. There's no need for approximating 2. 2. What are you approximating? 2. So you can have put 1 in, put 2 in, but there's no put 3 in. So this tells us that our answer is either A or our answer is B. Alright? So now let's pick the correct answer. If we start naming from here, we have 1, 2, 3, 4. So the methyl group is in the 4th carbon. So the name is going to be 4 methyl pent 1 in. It's as simple and sweet as that. The IUPAC nomenclature of the compound above. Alright, so this is what I was saying when I said that you'll be given some structures and then you will see halo group. Alright, the halo group. You see chlorine, bromine, fluorine, all of them mixed together. Now, how do you name this kind of compound? You know, the first thing I should take note of is there's something that you are seeing, OH. Right? You are seeing OH. So this tells you that this is going to be an alcohol. Right? It is going to be an alcohol. What does this mean? It means that we are going to have no. Right? So we need to get our parent carbon. What's the longest chain here? You have 4. 1, 2, 3, and then we have 4. So it means that our answer is butanol, but then we don't know which of the butanols, because you can see the whole option here has butanol, butanol, butanol. And this is what I was trying to tell you earlier, that the options I was giving you were very direct. Okay, but now the options that JAMB will give you will not be so that you can see that all the options here they look alike somehow. Okay, now one thing you should take note of is that you name accordingly. You name according to alphabet. You name alphabetically, which means that if you are naming B, is supposed to come before C. Take note to B is supposed to come before C. Now, let me say if I want to answer this kind of question, and then I don't know what I'm even doing. If I want to answer this kind of question and I don't know what I'm doing, I can eliminate 2 options from this question. Now, if you take a look at this option here, you have 2 bromo, 3 chloro, 2 bromo, 3 chloro, 2 bromo, 3 chloro. If you look at this, you have 3 chloro, 2 bromo. Hope you know this option A and then this option C. They're the same thing. Take a look at it. They're the same thing. The only thing is the arrangement, right? It is just the arrangement that is different, but then they are the same thing. So now what does this tell you? It tells you that if one is supposed to be correct, it means that 2 answers cannot be in a particular question. But then let us analyze the second one and see if it also looks like that. If you now look at option B and option D, you will see that you have 3 bromo, 3 bromo, 2 chloro, 2 chloro. So you can see that JAMB is very, very particular about the order, which means that you are meant to start with bromo before you move to chloro. right? But then again, that is not the main concern now. Now, when we are naming, because we know that our parent is butanol, our parent is butanol. So we are going to start from the carbon that has the OH group because we are meant to give honor to functional groups. Now, in the order of honor, you will honor functional group first before you honor substituent. Cl substituent, Br substituent, HO or OH is a functional group. So you honor functional groups before you honor substituent, which means that you are going to start from here. So you have carbon 1, you have carbon 2, you have carbon 3. But now, if you want to name, you will name from B before you get to C, which means that you are starting with bromo first, right? You start with bromo, then you go to chloro, then you go to chloro. Bromo, which carbon? Carbon 3, you can see it here, 3. So we have 3 bromo. Chloro is which carbon? Chloro, carbon 2, 2. So you have 3 bromo, 2 chloro, 3 bromo, 2 chloro, butanol. So option B is correct. You can see the procedures for naming this thing. But now, if you acknowledge that, okay, chlorine is in carbon 2, bromine is in carbon 3, but then if you don't arrange it very well, the option that you will go and pick is, this is the option that you will go and pick. You will go and pick this, D, 2 chloro, 3 bromo. Then you are not wrong. The only thing that makes this option wrong is because it is not arranged alphabetically. You arrange compounds, organic compounds, their names are in alphabetical order. When you have similar groups like the allo group, you arrange them alphabetically. Okay. So the next question, we have this. Now, this is a little bit tricky. This is a little bit tricky. As you can see, we have a lot of condensed, but this compound has been condensed. Now, remember, the first thing that we're going to do is to what? Separate, right? We are going to separate this compound. That's the first thing to do. We're going to separate this compound. So we have CH2, CH2. Then this CH2 is inside bracket 3. What this thing tells you is that you have CH2 into 3 places. That's the meaning of. That's why it is condensed. That's why it's called condensed. That's why it is called the condensed form, because they have condensed it. This is what this guy here means. This is what it means. So when we start counting, you should not go and count this as 1. You count it as 3. That's the reason for the emphasis. Right? So you have C. Remember that everything is meant to be, the middle is meant to be CH2. But now here we are seeing CH, which means that something has, there's the H, the other H has been replaced with something, right? That's what it tells us. So one H is intact, then the other H has been used to replace with something. What is that? This guy here, C3H7, C3, and then H7. That's what they used to replace it. That's the other H. Then you have your C2H5, C2H5. Please don't be confused. Remember I said that the two ends will always end with C3, CH3, sorry. The two ends will always end with CH3. But now you see that this end is ending with C2H5. It is the same thing. Don't allow JAMB to confuse you. Let's look at this structure now. Let me use another color so that I wouldn't confuse you. If you look at this structure here, right? This structure here. If I add CH3, CH3, CH3 here, and I add CH3 here, do you know that I can rewrite this structure? Like I can rewrite this thing. And when I rewrite it, this is how it's going to be. It's going to be like this C2H5, C2H5. Now you might want to ask me where did we get C2H5 from? If you combine these two together, you will get this. So this was what they did in this place. They combined the last two together to get C2H5 just to confuse people. Alright. Now let us pick the longest carbon. The longest carbon. Now, first, let us try straight. If we try straight, let's see what we're going to get if we try straight. That's like this. We try like this. Let's see what we're going to get. So this is carbon 1. This is carbon 2, 3, 4. So this is carbon 4, carbon 5, then 6, and then 7. Right? 6 and 7. This gives us what? Heptane. Heptane. But now there's something I want to tell you. That when you see questions that there are a lot of C, please don't be tempted to settle for your first longest chain. Try to look around and see if there's any other longest chain. When you see, in fact, your option should give you the idea. If you see option 1, 2 options pentane, 2 other options heptane, look at it very well. It means that check everything. When you check very well, you see that, oh, the highest is 5, then you can pick your answer. But when you see that there's 5, there's 7, sometimes JAMB used to use it as a trick because they know that people will just do the straight one, the one that is common, the one that is straight. They'll do it and they'll go. But don't do like that. After you see that, in fact, your option should tell you this option is already showing us octane and heptane. The first one we did is 7. This means that there's why did they put octane there? Because JAMB don't put options there to just put options foolishly. They put option to set trap for people, which means that there's a way that option can be correct. Okay, so the next thing for us to do is what other chain? What other chain can we do? Right? What other chain can we do? Let me use another color here. What other chain can we do? So we can do something like this, and then like this. Let's count how many carbons. This is carbon 1, this is carbon 4, 5, right? 5. So this is 5. 6, 7, and 8 because it's 3 carbon that is here. So this is 5, 6, 7, and 8. So you can see this one here is already giving us 8, which means that it's giving us octane. Octane. So automatically we are picking the highest, which means that propyl, heptane, these 5 propyl heptane, 3 propyl heptane, both of them are wrong. 2 options eliminated. So we have to work with 4 and 5. Right? We have to work with 4 and 5. Now, which means that automatically this guy you are seeing here, this guy here, C2H5, this one at the ending is now a substituent. It's now a substituent, right? So now let's name. If we use this order 1, 2, 3, 4, 5, it means that this substituent is in carbon 5, right? It's in carbon 5. And what is this substituent called? Remember the name. This is ethyl, right? Ethyl. We did it in the beginning. When you see things like this, 2 carbon and it's a substituent, ethyl, because this is meant to be ethane, but one hydrogen has been removed. That's why it's ethyl. So if you do it like this, you'll be having 5 ethyl octane. Remember, there is no option that JAMB will give you that is not a trick. So if the first one you did is 5 ethyl octane, try the other side. Now we tried from left to right. Now let us try from right to left. If we try from right to left, we are going to have this is already 3, this is already carbon 3, then this is going to be carbon 4. Carbon 4. So this is bounded to carbon 4, which makes 4 ethyl octane correct. It's as simple as that. It's as simple as that. Alright, so the next question we have is alright, so now let's name this. Let's name this. This is quite simple. You already know if we pick the longest carbon chain, this is 4, which makes it butane, right? This makes it butane. Butane. Then if we name 1, 2, 3, 4, the naming is already there. The counting rather is already there. So this means that this substituent is in carbon 2, right? So this makes this guy 2 methyl butane. It's as simple as that. Alright, so let's look at the second one. We have something like this. This is still butane, right? This is still butane. 4 is still butane and it is single bond, so it's butane, right? So now if we name it like this, if we count it from left to right, it means that one of the butane is in 2, one of the butane is in 3, right? If we name it from right to left, it will be 1, 2, 3, and 4. It is still the same thing. It's still the same thing, right? So 1, 2, 3, and 4. Now what does this mean? This means that the name of this compound is 2, 3, how many methyl? 2 methyl, which makes it di. So it will be dimethyl butane. So 2, 3 dimethyl butane. That's simple. Naming of compounds, organic compounds, is as simple as anything you can think of. Just know the tricks and then know the rules. You are good to go. Okay. So now let's look at this. We have 1, 2, 3, 4, and 5. Right. Now this is the longest chain that we can get. But let's still look at if we can see any other chain. This is 1, 2, 3, 4, 5. If we go like this, this is 1, 2, 3, 4. This is 4. 1, 2, 3, 4. This is 4. So 5 is the longest, all right? 5 is the longest. 5 is the longest. If we count from right to left, we'll find out that the 2 methyl group are still in the 3. So we now have 3, 3 dimethyl 1, 2, 3, 4, 5 dimethyl pentane. Now, when you see something like this, most of the time, let me just add this. All right, this is going to be the second thing I'm talking about in this video that is not nomenclature, isomerism. It will tell you that this is an isomer of which homologous series, right? Which member? This is an isomer of which member? It is not hard. It is very, very simple. Now, when you see something like this, pentane is already 5, right? How many methyl are attached? 2, 1, and 2. This makes it 7. 5 plus 2. This makes it 7. So this is an isomer of heptane. If you go back, let's go back. This is 4 and 2. This is an isomer of hexane. Let's go back. 1, 2, 3, 4. 4 plus 1 because it's 1 that is attached. 5. This is an isomer of pentane. So if you see anything related to isomers, very, very simple. Okay, but that's not the topic of our discussion in this video, so we're not going to digress much on that. All right, so now let's look at this. The numbering already has given us the longest carbon. Okay, remember I said it is not every time that the longest carbon will be like this. It is not every time that it will be like this. Sometimes it can be like this. The way it is numbered here, it can be like this. Right. So whichever way we decide to name it, you will see that this guy here is what is carrying these two methyl group, this and then this. So if I name from up to down, 1, 2, 3, 3, that's 3 di methyl. How many carbon? 1, 2, 3, 4, 5. Pentane. Dimethylpentane. 333 dimethylpentane. If I decide to name from down to up, this will be carbon 1, this will be carbon 2, this will be carbon 3, this will be carbon 4, this will be carbon 5. 333 dimethylpentane. You can see this guy here and this guy here, they are the same thing. You can see JAMB can be very tricky. This number 3 and then this number 4, they are the same thing. They're the same thing, same structure, same structure. All right. So now let's look at this and name this. This one is very simple. I think we have named something similar to this before. So this is correct. CH3 is always the ending. CH3 is always the ending. Is also correct. CH2 is in the middle. Correct. This now C is carrying methyl and then it's carrying chlorine. Which one is going to come first out of chlorine and methyl? It is chloro that will come first. So if you are naming, you count from here 1, 2, 3, and 4. Because obviously the functional group, this is the closest, right? So we now have 2 chloro, 2 chloro, 2 methyl. What's the family group? Butane. 1, 2, 3, 4 butane. And it's as simple as that. All right. So I think this should be the last question for the crash course video on organic chemistry nomenclature. All right. So I want to believe that with this video, you are now ready for any nomenclature question that is going to come out in your UTME. All right. So once again, I want to wish every one of you success in your upcoming UTME. You should believe in yourself, trust in yourself. You are prepared for this exam. You have read. You have. In fact, the fact that you are watching this video shows that you are putting in effort to prepare for this exam very well. Right. And I want to wish you success. And I know that you are going to do so well. All right. Don't forget to reach out to me if you need any help. There are summaries, free crash course to access. All you need to do is to show your interest in the comment section, and I'm going to reply you with a link. They are going to reach out to me on WhatsApp, and then I'm going to send you and grant you access to those files on Google Drive. All right. If you have watched this video to this point, please do not to hit the subscribe button. Don't just watch and then you benefit and just go. Ensure you hit the subscribe button. Tell your friends about this channel. Tell your friends what you are benefiting from this channel. Ensure you share this video to your friends. Share this video to your group chat. Share this video to your classmates. That every one of you will pass. All right. So ensure you do practice for this topic. Okay, the organic chemistry nomenclature. It's very, very important that you practice more questions. Go to your past question. Go to sites. Go to different avenue that you can use to practice. Just ensure that you get more questions to practice. And it will be very, very nice if also you can drop in the comment section what you learned new from this video right there. For those of you who are going to be doing biology, anticipate there's a video I am also cooking and preparing. The video is going to consist of diagrams that you should be expecting in JAMB. So don't want to anticipate that video. If you're interested in that video, let me know in the comment section. See you guys in the next video.